All right, so like I said, yesterday we went over a lot of basic rules, and then we did three examples, okay? Um, and what we're going to do today is we're going to continue with these examples, kind of do some of them that are a little bit more complicated, um, and from there we'll move on to maybe doing some definite integration, okay? But let me give you another example for us to try out. So example number, let me see, 1, 2, 3, 4. So this would be 5. And we're going to find the integral of x squared plus 2x plus 1 dx. Now again, I'm going to do this kind of like the way all the rules would apply to it. Usually people, once you get used to it, you don't apply the rules, you just do this in your head. But it takes practice, right, to do it quickly. So this is what it would look like if you start off using the rules that they're given. So you see three main terms. So I'm going to break it up into three different problems. Okay, so there are my three integrals. Okay, three terms, three integrals. Now you don't always have to do this, but at first sometimes it helps. Now, for the first integral, that's just a basic power rule integration. Okay, so for this one, I'm going to write x to the 2 plus 1 over 2 plus 1 plus c. That's the first integral. Okay, x to the 2 plus 1 over 2 plus 1 plus c. Now, the next integral, I'm going to take an extra step. Again, I'm just using the rules that they give us. And I'm going to take the 2 out. I'm going to ignore it and then only work with that function. So in the next step, I'll actually do the work for it. And then for the last integral, there was a rule that they showed us that said if you had the integral of k dx, then your answer would be kx plus c, where k is just a constant. Notice for me, 1 is just a constant. So that means the integral of 1 dx is just 1x. Actually, let me change that color. But this would just be 1x plus c. And I'm going to kind of put it just in a bracket just so you can see that last piece. So 1x plus c. Now I'm going to simplify a little bit. So on the left side, I get x cubed over 3. Now the plus c's, I'm going to add them together at the very end. So I'm going to ignore it for now. Plus 2. All right, now I got to integrate x dx. So x dx would be x to the 1 plus 1 over 1 plus 1 plus c. So that's that middle integral that I never did. Now 1x is just x. And then I do have a plus c at the end plus another c, while a constant plus a constant is still just a constant. Okay, so remember, this part right here gave us that. Okay, the x squared dx gave us the x cubed plus 3. All right, the 1 dx gave us that part right there, the x plus c. And then that 2x dx, I first rewrote it like this so that I can get this answer right there. Okay? So I'm just kind of showing you like step by step what it's supposed to look like. When you get better at this, you guys are going to look at the top function and say, okay, that's x cubed over 3 plus x squared plus 1 plus c. Okay, you'll be able to do that. But sometimes at first it just takes time for us to kind of process everything. So let's go ahead and simplify this so we can finish up here. So we have x cubed over 3 plus 2 times, this will be x squared over 2 plus c plus x plus c. Now just distribute and simplify. So we have x cubed over 3 plus, now distribute that 2, you get x squared, because the 2's will cancel, plus 2 times c is just a constant, so I'm going to add that to the constant at the end. So twice the constant plus a constant is just going to be a constant. So I'm going to put x plus c, and that's my integral. So I know it looks a little messy, but right now I'll kind of walk us through it up on the board. So let me just pause this really quick. I'm going to go ahead and show you example 6 right now. Again, the ones that we're doing right now are a little bit more complicated because I don't just want to show you the easy stuff that we did yesterday and then you're thinking, oh, this is no big deal. And then you see these problems and you're like, what happened to the ones that look like the ones we did yesterday? But I'm also trying to show you like techniques, like what do you do in case you see something like this? Like how do you fix it? Because right now you look at what I gave you and it looks really complicated. But in Algebra 1, we learned that if you have two terms, okay, added or subtracted together, and you're dividing it by a third term, you could actually break them up into two fractions, right? So that's what I'm going to do with this problem. I'm going to write the integral of x over radical x plus 1 over radical x dx. Now, according to the basic rules of integration, if you have addition or subtraction inside, you can break it up into two different problems. So that's what we're going to do. I'm going to break it up into x over radical x dx as one of them, and then the integral of 1 over radical x dx. So now I have two problems I got to work on. Okay? Well, these are fractions and we don't have a quotient rule. So I told you guys have to create power rules. So let's rewrite our problem here. This is x over x to the half dx plus 1 over x to the half dx. Well, since they both have the same base, at least the first integral, I can subtract, right? X to the first divided by x to the half. This would be x to the half dx. Now the other one, I can't simplify it by, dividing it out, but I could get that x and move it up and write it as x to the negative half dx. And now I just have a power rule. Okay, for both of them. So I just got to add 1 to the power, divide by the new power, right? So here we go. For the first one, it's x to the half plus 1 over half plus 1 plus c. Plus the next one, x to the negative half plus 1 over negative half plus 1 plus c. Now remember, these constants will just join up together, so I'm going to probably get rid of them on the next step and just make one c instead of two different c's. But let's go ahead and simplify those fractions. And I'm going to write them out the way most people will, and then we'll fix them later. Usually I just fix them right away, but let's do it the way most people will attack this. So half plus 1, that's 3 halves. So it's x to the 3 halves over 3 halves plus negative half plus 1, that's a half. So x to the 1 half over 1 half plus c. Now remember, whenever you're dividing by a fraction, it's the same as multiplying by its reciprocal, right? So instead of x to the 3 halves divided by 3 halves, I'm going to write it 2x to the 3 halves over 3. Because I multiplied by 2/3, right? Instead of dividing by 3 halves. Plus, for the next one, I'm going to write 2x to the half divided by 1, but I'm not going to put divided by 1. I'm just going to leave it like that. And then plus c. And there's your answer for this one. Bless you. So, again, it does look at first like it's going to be really difficult, but if you break it apart and write it as two different problems, kind of simplify them as much as you can. Remember, we don't want to do any type of things where we're multiplying stuff together or dividing things together, because we don't have rules for that. We don't have quotient rules. We don't have product rules. Okay? So we have to rewrite stuff, make it fit what we know how to do. So once we do that, then we can start integrating and just kind of taking your time, making sure you don't accidentally mess up on the easy part. We want to say the algebra part, right? The dealing with the fractions, adding one, that type of stuff. Hopefully we don't mess up on that, and then you should be able to get your solution. Any questions on this one? I mean, it's not easy, but it's not, I mean, once you see it done, it's not like totally hard. It just takes a little bit of ingenuity. You got to think your way through this, right? Don't just say, they gave me this, I have to deal with it. No, break it down, okay? Break it down to make it fit what you need to do. So here's example 5, 6 is 7. We're going to find the integral of cosine of x divided by sine squared x dx. Again, you should notice this is a fraction. We don't do fractions, right? We got to fix this. So the question is, how do we fix this? Okay? So the way we're going to fix this stuff is we're going to try to use some trig to make this easier for us. Okay? So yes, you do have to remember that stuff, right? So what I'm going to do, I noticed that there's two signs on the bottom, right? Sine squared x. So I'm going to write it like this. Cosine of x over sine of x times 1 over sine of x dx. You guys okay with that? I just split it apart. Right? I know there's two signs on the denominator, so I'm going to use them as two different fractions multiplied times each other. Okay? Now there's a reason why I did this, because what is cosine over sine? That's cotangent of x, right? What's 1 over sine? Cosecant of x. And don't I have a property or a rule that tells me what the integral of cotangent x cosecant x dx is? What is the answer to that? Is it negative or positive though? It's negative, right? Negative cosecant x plus c. And there you go, you're done. So yeah, the problem looks really tough at first, but again, you gotta use your ingenuity. You gotta say, okay, what do I know about these functions? What can I do based on my previous knowledge to these functions? Right? Like, how did I mess with these before? What did I used to do? And then once you figure it out, it's really quick. It doesn't take very long. Okay? You're just trying to make it work for you. So, let me see. I'm just trying to check something here. All right. So, we're going to do position functions right now. Okay, so they're going to want us to do this. So let me go over this with you guys. So let me write the problem down and then we'll discuss it. All right, so this is kind of wordy because it is a word problem. So they say a ball is thrown vertically upward from the ground with initial velocity 60 feet per second. How high will the ball go? How high will the ball go? Now we got to assume, okay, you guys always have to know this. You have to assume acceleration due to gravity. Okay? So, if you're taking physics, you might know this. If you haven't, well then you're about to learn this. Acceleration due to gravity is negative 9.8 meters per second squared if you're dealing with meters and seconds. Okay? Or negative 32 feet per second squared if you're dealing with feet and seconds. So they may not tell you in a problem what acceleration is because they're assuming you should know. Okay? So there are two measurements that we tend to use, either negative 9.8 meters per second squared or negative 32 feet per second squared. Okay? So make sure you guys kind of write that down. You got to understand that. So we are going to basically try to do two things. We're going to find the position function. Okay, number one, find the position function. Okay, that's our first goal. And second goal is find the height. All right, so how do we find position function? Because I know some of you guys, maybe you took physics here, like, oh, I know S of t is equal to half AT squared plus V naught t plus S naught. Position function, I got it, right? And then others are saying, I have no idea what he just said because I haven't taken physics, so I don't know what you're talking about. Here's the thing about calculus. You can find position functions by integrating, by starting at one point and moving backwards till you find that position function. So let me show you what I'm talking about. So first off, let's list things that we know. Okay, things that we know. They say a ball is thrown vertically up. So if it's thrown upwards, its velocity is positive or negative? Positive, right? They say thrown upward from the ground. So what's the initial position of this thing? So S is our position function, just so you know. So actually, before I write that down, just so you guys know, S of t is a position function with time as the main variable, okay? So S of t is our position function. What would S prime of t be? We've talked about this before. So if you take a derivative of position, what do you get? Maybe you don't remember, but yeah, it's velocity, right? Velocity based on time. If you take two derivatives of position, which would basically be one derivative of velocity, what do you get? Acceleration, right? So we're going to get acceleration based on time. Okay? Before we stop, let me just write down the things we know, and then we're going to stop. Okay, there's just two little things that we know. According to the problem, I know where we started, right? A ball is thrown vertically upward from the ground. So what's my initial position? It's 0, right? So my initial position, let's say S of 0 is 0. In other words, when time was 0, my height was 0. So S of 0 is 0. What else do I know? They say it has an initial velocity of 60. Initial velocity, V sub naught, right? Or we could call it S prime of 0. In other words, velocity when time was 0. I can call it V of 0, right? Initial velocity, which is S prime of 0. What is it? What's the initial velocity? 60 feet per second. Right, by the way, this would be 0 feet. And I know one more thing. Since this is in feet per second, don't I know acceleration? Right? So acceleration at any time, okay? So at 0, at 30, at whatever. But acceleration at any time is negative 32. So I'm just going to write V prime of t. By the way, you don't have to do what I'm doing right now, writing like A of t equals V prime of t equals S double prime of t. I'm just trying to show you the relationship between them, okay? And that would be, what did they say? Acceleration due to gravity, it should be negative 32 feet per second squared, right? So we'll stop there. Tomorrow we're going to actually start building the position function, and then we'll get this problem done, and we'll be done with the lesson.